STEM science.
All right, let's take a look at the third type of sort of charging that we're going to explore here. This is called charging by induction, and this is going to result in a temporary charge. And you'll see what I'm talking about in a second. What I want to sort of indicate here is that this is charging by induction, not by contact. So what I mean by that is that this object here, or these objects here, are not going to touch, because as soon as they touch, that's charging by contact. These will not touch at all. They will get close to each other, but that's about it. All right, so what's happening here? Let's take a look. We've got one charged object here, and it looks charged right away because you can see there's already an imbalance of charges. We've got what do we got here? 9 negative charges compared to the 6 positive charges here. So you can see that this overall is a negatively charged object. Down here, we've got equal amounts of negative charges and positive charges. So this is a neutral object. So what's going to happen is, well, what happens when this object here gets close to the neutral object? Well, because this is negatively charged, this goes back to that law of charges where uh, objects or charges that are the same, whether it's negative, negative, positive, positive, when charges are same or similar charges come close to each other, they're going to repel. And that's exactly what happens here. This object, which is overall a pretty negatively charged object, gets close to this neutral object. The negative charges, and again, it's only the negative charges that can move within an object or shift in an object, which is what we're about to see here. The positive charges are stuck. Like I said, they're proton-based, so they can't move at all. They're locked to the atom. But the negative charges can move. And so when this negatively charged object gets close to this neutral object, the negative charges within that neutral object are going to be repelled. And in fact, they're going to try to get away from that negatively charged object. And you're going to start to see them sort of fly down here and sort of move, sort of orient themselves away from this nearby, but not touching, but this nearby negatively charged object. Now, just to be absolutely clear on this, this is still a neutral object. It's still got the same number of positives as they do, the same number of negative charges. So this is neutral. But what's really interesting here is that because these negative charges have shifted away from the one edge of this object, we can kind of say that this edge here, you can see we've got sort of like a clumping or a sort of a gathering of negative charges on one side of this. This is actually kind of negative-ish on this side of the object that's furthest away from this negatively charged object. So this has got a sort of a negative charge sort of to it. On this side, the only things that are left are these positive charges. So this actually has kind of a positive sort of side to it. And as a result, this neutral object, because of this positive side being close now to this negatively charged object overall, these two objects are going to start to become attracted to each other, even though overall this is still a neutral object. So that's what we mean by charging by induction, that this neutral object is kind of behaving like a charged object. And it's only doing it because of this charged object getting close to this neutral object and basically pushing the electrons, in this case, away from it, leaving a positive side on one side and a negative side on the other. And if we were to sort of label this off, this is what we're talking about here. Overall, this is neutral, but you can kind of see we've got this induced positive side and this induced negative side. And because of this positive side being close to this negatively charged object, these two objects are going to start to becoming attracted to each other. But again, once this object, this negatively charged object, moves away and leaves, these negative charged objects will simply just sort of reorient themselves so that they are sort of back into here like this. And you're left with this neutral object as it was before. And as a result, this is only a temporary type of setup, only when this charge object gets close to it. So that's why we call this charging by induction, resulting in a temporary charge. All right. The other thing I want you to consider here is we could change it so that what we're looking at is a positively charged object, and this positively charged object coming close to, again, a neutral object. Well, what's going to happen here? Again, we only have to deal with the negative charges because those are the only things that can actually move or shift. And again, this is charging by induction, so these objects actually are never touching. They're just going to get close to each other, but that's about it. Now, because this is a positively charged object, it's going to be attracted to other negatively charged objects, meaning that these electrons that are here, or these negative charges that are here, are going to start to move towards this positively charged object. You can kind of see them shifting like that. There they go. Oops, sorry, that's a little wrong. There we go. This guy's going to move up into here, and I don't know what I just did there. This object, this negatively charged object is going to start moving into there like that, and this negatively charged object, negative charge is going to start moving towards this edge here because again, they're attracted to this positively charged object. And like we said before, look what happened as a result of that. What we end up having here is, even though this object is overall neutral, this side now takes on this sort of negative-ish sort of charge, and this end here takes on a bit of a positive-ish charge. And because this negative side to this object is close to the positively charged object, these two objects are going to be attracted to each other. This neutral object behaves kind of like a charged object. But again, it's only temporary because once this positively charged object is removed, these electrons will simply just sort of go back to their sort of original configuration, and you lose that sort of negative-ish side and that positive-ish side, and you're now left with a regular neutral object. So there it is. That is charging by induction, resulting in a temporary charge.